All right, this picks up where we were at the end of the first video on transformations. We are still just talking about vertical and horizontal shifts. This says absolute value of x minus 4. What I have here is a blank graph because that's what you're going to have when you try to do these on your own. To be able to do these, you have to realize that my original function is just the absolute value of x. You have to know what that looks like. We know absolute value is a v, but where is that v? You know, how fat is it? How skinny is it? We do know it's through here at the origin. One way to know for sure is, again, look at your t-chart. And I'll just look at a couple of them. Do -1, 0, 1, put those into the absolute value. It all turns positive. And I'm looking at -1, 1, 0, 0, 1, 1. And this would be my absolute value if I can draw this correctly. That's what my v, original v, will look like. Now, I put it on the next screen where it looks a little bit better. That's the basic absolute value. Absolute value, these two, another way to think about this is to remember that these are just like a line going through the origin. See, right through there with a slope of 1. So that's how I know that those are in those positions. To do this, I have to realize -4 because it's happening after the absolute value function. This is just going to move down 4. So you will take individual points and move them down 4. And you don't have to take a bazillion of them. I'm going to take this one down 1, 2, 3, 4. Take this one, go down 1, 2, 3, 4. I'm off the graph a little. Take this one, go down 1, 2, 3, 4. Knowing that this is an absolute value, it makes a V. When I move it around, it will still make a V. And it will look something like this, of course, with straight lines. I've already said I have a hard time drawing with this tool. All right, cube root of x plus 2. This is a basic variation on the cube root of x. We haven't looked at a t-chart yet on the cube root, so let's do that because we have to know how to start this thing. I know, looking at this is going to be very easy. This plus 2 is going to tell me to move all of my points to the left 2. That's what the rule is that we established in the last video. But I don't have a graph here yet, so I have to do a little bit of t-chart work here to get these numbers. This is cube root, so the numbers I'd like to choose should be perfect cubes. So maybe I'll do -1, 0, +1. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And that might not be enough because if I plot those, -1, 1, 0, 0, 1, 1, that looks like a line, and cube root is not a line. So I should maybe do 2, or I should maybe do 8. Cube root of 8 is 2. So over 8 up 2, see that's going to be way over here somewhere. And -8, -2 will be way over here somewhere. Of course, you need to do a little bit of memorizing, and that is the cube root does this little squiggly thing. So I'll try to get this here. It comes through. It kind of goes down. That's a horrible looking picture. That's why I've got it drawn over here a little better. So remember what my chart numbers were. That was 0, 0, 1, 1, 8, 2, which will be up in here somewhere, -1, -1, -8, -2. This is why I said in the first video you need to do some memorizing, and that is cube root does this little squiggly thing hitting those kind of points, and then you can approximate from there. So as I said on the last screen, now that I have this is inside the function. It's with the x, therefore it's a horizontal thing. The horizontal thing does opposite of what it looks like. That says +2, so I know all of these points need to move to the left 2. So I'll take this point and go over 2 to the left. This one over 2 to the left. This one over 2 to the left. And then I need my curve to approximate this, and I'll do the best I can here. It's going to kind of squiggle through here and come. It'd be really nice if I could move this up and you'd see that, but that's what this will look like. You could probably draw it better with a pencil than I can on the screen here. Now this is double changing. We've got something inside with x, which makes it a horizontal thing, and this outside, which makes it a vertical thing. This is absolute value, which means we know it's this v thing, and I just told you one way to remember the v, it's like a line coming through here with a slope of 1. So that's what that would look like. Well, that's what that looks like. That's my original absolute value. I need to look at these two things. Inside with the x is a horizontal thing. That tells me this is going to go to the left 1. Then outside the bars tells me it's a vertical thing, and this is going to go up 2. So each of these points that I'm going to use are going to go left 1 and up 2, and I can do them at the same time. Take this point right here, go left 1, up 1, 2, there's a new point. Take this one to the left 1, up 1, 2, that's a new point. That one to the left 1, up 2, and you see connecting this is going to still be a V. If I can draw it, that's not too bad. And you can see that if I could take this whole V, shift the whole thing over 1 and up 2, it would land right on that. Now sometimes you have these just funky looking functions. There is no absolute value or square root or anything like that you have to memorize. The graph is already drawn, which really is easier to do than those other ones. The other ones, like this one, to be able to get this graph correctly, you have to know absolute value is a V. To graph this back here with the cube root, you have to know that the initial graph is this little squiggly through the origin. But one of these, where it just identifies the function and it's already drawn, all you have to do is decide how to move this thing. So we look at this. This 2 is inside with x. That makes it a horizontal thing. That says x minus 2. So we do the opposite, which means we move the points to the right 2. This 1 out here is after the f of x, plus 1. Tells me I'm going to take those points and move them up 1. So I'm going to take like this point, this point, this point, this point, and those should be enough for me to approximate what it's going to look like. So take this point and go to the right 2 and go up 1. Happens to land right there. Take that one that was a red one to the right 2, up 1, to the right 2, up 1, and to the right 2, have to fake it a little bit, up 1. And then I know how to connect this. When I connect these green dots, it needs to approximate the shape that I had there with my blue. And the green there is the graph of this f of x minus 2 plus 1. So that finishes up our horizontal and vertical shifting. If it's inside with the x, it's a horizontal thing. If it's outside, it's a vertical thing. If it's a horizontal thing, it's opposite. X minus 2, maybe go to the right 2. Once we identify it as a vertical thing, it's exactly what it looks like. Plus 1 would move it up 1. Had this said minus 1, we'd have gone down 1. So the next video we'll pick up and do what's called reflections.